Top 1. Tyrannosaurus rex, the Tyrannosaurus rex. In 1902, deep within the arid Badlands of Montana, a paleontological expedition led by the American Museum of Natural History uncovered a massive skull protruding from ancient rock layers. The excavation site was remote, silent, and seemingly untouched for millions of years. As the team carefully removed layers of sediment, they revealed a creature of staggering proportions. Its skull alone measured over 5 feet in length, lined with serrated teeth the size of railroad spikes. The discovery would later be named Tyrannosaurus rex. But what truly unsettled the researchers was not just its size. It was the evidence embedded in fossilized bone fragments nearby. These bones were crushed, splintered, and punctured in ways that suggested unimaginable force. This was not merely a scavenger. This was a precision killing machine, and the Earth had once belonged to it. Detailed biomechanical studies conducted decades later revealed that Tyrannosaurus rex possessed the most powerful bite force ever recorded in a terrestrial animal, estimated between 8,000 and 12,000 pounds per square inch. Its teeth were not designed like blades for slicing, but like thick conical daggers built for puncturing and crushing. Fossil evidence shows healed bite marks on the bones of other large dinosaurs, including Triceratops and Edmontosaurus, indicating that some victims survived initial attacks only to be hunted again. Advanced CT scans of T-Rex skulls revealed reinforced bone structures capable of withstanding extreme stress during violent feeding. Its forward-facing eyes provided binocular vision, allowing precise depth perception. Combined with an acute sense of smell, comparable to or exceeding that of modern vultures, T-Rex could track prey across vast distances. Every anatomical feature pointed toward a predator engineered for dominance. When the first complete skeletal mounts were displayed in museums, the public was awestruck. However, behind the scenes, scientific debates intensified. Early hypotheses that Tyrannosaurus rex was merely a slow-moving scavenger were gradually dismissed as new evidence emerged. Bite marks matching T-Rex teeth were found on prey bones in positions consistent with active predation. Trackway analysis suggested bursts of surprising speed for an animal weighing up to 9 tons. As these findings gained traction, some early interpretations and museum descriptions were quietly revised. Previous models depicting T-Rex as sluggish and passive were removed from exhibits. The narrative had shifted, but not without resistance. For decades, the true predatory nature of Tyrannosaurus rex was downplayed, as if the full extent of its lethality was too extreme for early scientific consensus to accept. If Tyrannosaurus rex truly operated as the apex predator that fossil evidence suggests, then the ecosystems of the late Cretaceous were governed by a level of predatory pressure far more intense than previously imagined. Entire herds would have lived under constant threat from a hunter capable of detecting, pursuing, and annihilating prey with brutal efficiency. Modern reconstructions using muscle density and bone stress modeling continue to revise its strength upward, not downward. Each new discovery paints a more formidable picture than the last. If a creature with such sensory precision, crushing force, and predatory intelligence were to exist today, the balance between human technology and natural supremacy would be tested in ways never before experienced. The question is no longer whether Tyrannosaurus rex was dangerous. The real question is how any ecosystem, past or present, could ever feel safe under the shadow of a predator built to dominate everything in its path. Top 2. Spinosaurus. The Spinosaurus. In 1912, deep within Egypt's Bahariya oasis, German paleontologist Ernst Stromer uncovered fossil remains unlike anything the scientific world had seen before. Towering neural spines rising over 5 feet from the vertebrae formed what appeared to be a massive sail along the creature's back. Its skull was long and narrow, lined with conical teeth resembling those of a crocodile rather than a terrestrial dinosaur. The discovery was documented, cataloged, and stored in Munich. But in 1944, during an Allied bombing raid in World War II, the museum housing the original fossils was destroyed. The specimens vanished in flames, leaving behind only sketches, photographs, and unanswered questions. For decades, Spinosaurus existed as a scientific ghost, recorded but unverifiable, and then nearly a century later, it returned in a form no one expected. In the early 2000s, Fossil hunter Hassan II and paleontologist Nizar Ibrahim traced scattered bones across the Kem beds of Morocco, eventually reconstructing a predator that defied conventional dinosaur anatomy. Spinosaurus measured up to 50 feet in length and weighed as much as 8 to 9 tons, rivaling or exceeding Tyrannosaurus rex in size. Yet its body told a different story. Its hind legs were unusually short, its bones dense like those of aquatic animals, and its tail formed a broad, flexible fin capable of generating powerful thrusts through water. High-resolution CT scans revealed pressure-sensitive receptors in its snout, similar to those found in modern crocodiles, enabling it to detect movement in murky waters. This was not merely a dinosaur that fished. It was a fully adapted aquatic predator, the first of its kind ever identified among large theropods. The implications were staggering. For over a century, the dominant scientific model portrayed large predatory dinosaurs as strictly land-based hunters. Spinosaurus shattered that assumption. Robotic tail simulations and hydrodynamic testing confirmed its efficiency as a swimmer, capable of pursuing large prey through vast river systems that once cut across prehistoric North Africa. Its environment was a lush network of waterways teeming with enormous fish like Onchopristis and Mawsonia, some stretching over 20 feet long. Within this domain, Spinosaurus was not an intruder from land. It was the apex authority of a submerged empire, striking from below with speed and precision. Yet the path to accepting this reality was marked by skepticism and quiet resistance. Early reconstructions depicting Spinosaurus as a shoreline wader persisted for years, even as mounting fossil evidence suggested a far more aquatic existence. Several critical specimens were held in private collections, delaying broader scientific verification. Access to key excavation sites in politically unstable regions remained restricted, slowing independent confirmation. As revised models emerged, museum exhibits and academic publications were gradually updated, often without public acknowledgement of how dramatically the narrative had changed. A predator, once imagined as awkward and secondary, was revealed to be a dominant force in an ecosystem unlike any previously understood. If Spinosaurus truly mastered both land and water, then the prehistoric world was far more strategically dangerous than modern ecosystems. Riverbanks, deltas, and shallow seas, areas that today offer life and refuge, would have been zones of constant, invisible threat. Satellite mapping of ancient river systems continues to reveal habitats perfectly suited for such a predator, suggesting its dominance may have extended across vast regions of prehistoric Africa. This raises a chilling possibility. If evolution once produced a giant predator perfectly engineered to hunt across environmental boundaries, then the concept of safe terrain may be nothing more than a temporary illusion in Earth's long biological history. Top 3. Megalodon, the Megalodon. In 1875, aboard the HMS Challenger during the first global oceanographic expedition, researchers dredging the depths of the Pacific Ocean recovered several massive shark teeth embedded in deep-sea sediment. Each tooth measured over 6 inches in length, far larger than those of any known shark. When analyzed, scientists estimated the surrounding sediment to be millions of years old, yet the teeth appeared remarkably well preserved. The discovery sparked immediate intrigue. If these teeth truly belonged to an extinct species, their condition suggested a far more recent presence than expected. Official conclusions eventually labeled them ancient relics displaced by oceanic activity, but the anomaly lingered. Something about the ocean's depths did not align with the timeline, and the predator those teeth belonged to was Otodus megalodon. Reconstructed from thousands of fossilized teeth and vertebrae found across every major ocean, Megalodon is estimated to have reached lengths of 50 to 65 feet and weighed up to 70 tons. Its bite force has been calculated between 24,000 and 40,000 pounds per square inch, making it the most powerful bite ever attributed to any known animal. Its jaws could open wide enough to swallow 2 adult humans standing side by side. Serrated teeth, designed for cutting through bone and blubber, were arranged in multiple rotating rows, ensuring that broken teeth were instantly replaced. Fossilized whale bones discovered in regions such as Peru, Chile, and the southeastern United States bear deep gouges and embedded megalodon teeth, clear evidence of violent and targeted attacks. Unlike modern great white sharks, megalodon often struck from below, shattering ribs and vital organs in a single, high-velocity impact before returning to finish the immobilized prey. Marine simulations based on fossil distribution and ocean temperatures reveal that megalodon dominated warm coastal waters, particularly nursery regions where young whales gathered. Juvenile megalodons, already measuring up to 20 feet long, developed in these protected environments before moving into the open ocean. As apex predators, no marine creature of its time could challenge a fully grown megalodon. Its presence alone would have reshaped migration routes, feeding behaviors, and the evolutionary trajectory of marine mammals. Entire ecosystems adapted not to compete with it, but to avoid it. Despite its official extinction around 3.6 million years ago, the ocean continues to present unsettling gaps in certainty. More than 80% of Earth's oceans remain unexplored, and the deep sea, particularly regions exceeding 10,000 feet, remains largely beyond continuous observation. Throughout the 20th century, deep-sea cables were occasionally discovered bearing enormous bite marks, far exceeding those produced by known marine species. During naval sonar operations in the Cold War era, operators intermittently recorded massive, moving objects at depths and speeds inconsistent with any documented marine life. These events were routinely categorized as unidentified biological contacts and archived without further public explanation. Meanwhile, rare but persistent reports from fishermen and deep-sea crews describe colossal, shark-like silhouettes moving beneath vessels in remote waters. Scientific consensus maintains that megalodon could not survive in the modern ocean due to temperature shifts and the decline of its primary prey. Yet discoveries of thriving, extremophile ecosystems around hydrothermal vents and in deep ocean trenches have demonstrated that life can persist in conditions once deemed impossible. The deep ocean remains a realm where absence of evidence is not evidence of absence. If a predator evolved to dominate the ancient seas with unmatched size, force, and efficiency, its disappearance marks not just an extinction, but the end of an era of absolute marine supremacy. But in a world where vast underwater regions remain unobserved, the certainty of that extinction rests more on assumption than continuous proof. And in the deepest parts of the ocean, where sunlight has never reached and surveillance has never endured, the possibility remains that the age of giants did not entirely end. It simply descended beyond our sight. Top 4. Giganotosaurus, the Giganotosaurus. In 1993, deep within the windswept Badlands near Villa El Chocón in Patagonia, Argentina, a local mechanic named Rubén Darío Carolini stumbled upon a massive fossil protruding from the rocky ground. What began as a chance discovery quickly escalated into one of the most significant paleontological revelations of the 20th century. When professional paleontologists arrived and began excavation, they uncovered the remains of a colossal predator unlike anything previously documented in South America. Measuring over 40 feet in length and weighing nearly 9 tons, the creature was named Giganotosaurus carolinii, the giant southern lizard. But its true significance extended far beyond its size. It represented a predator built not just for power, but for sustained, calculated hunting across vast prehistoric landscapes. The dominance of Tyrannosaurus rex was no longer uncontested. Detailed anatomical analysis revealed a predator optimized for speed and endurance rather than brute-crushing force. Its skull, stretching nearly 6 feet long, was lighter and more flexible than that of T. rex, lined with blade-like, serrated teeth designed to slice deeply into flesh and cause catastrophic blood loss. Its long, powerful legs and balanced tail suggested it could reach speeds of up to 30 miles per hour in short bursts, an extraordinary feat for an animal of its scale. Unlike ambush predators, Giganotosaurus was engineered for pursuit. Fossilized trackways and biomechanical modeling indicate it could maintain efficient movement over long distances, making escape nearly impossible for even the largest herbivores of its time. Its world was dominated by giants, towering sauropods such as Argentinosaurus, stretching over 100 feet long and weighing up to 100 tons, roamed the floodplains of Cretaceous Patagonia. No single predator, regardless of size, could reliably subdue such immense prey alone. This reality led scientists to a compelling hypothesis. Fossil discoveries in the same geological formations revealed multiple Giganotosaurus individuals living within overlapping territories, alongside related species like Maposaurus, whose bone beds strongly suggest coordinated group behavior. While direct proof of pack hunting remains elusive, biomechanical simulations demonstrate that coordinated attacks targeting vulnerable areas, legs, flanks, and tail, would have allowed these predators to bring down even the largest dinosaurs on Earth. The landscape was not ruled by a lone hunter, but potentially by organized killing units. The scientific community responded with both excitement and caution. Early media portrayals framed Giganotosaurus as a definitive rival to Tyrannosaurus rex, igniting intense academic debate. Many initial comparisons were tempered or revised as more complete fossil data emerged. Reconstructions of its posture, musculature, and hunting behavior evolved rapidly, and earlier interpretations quietly disappeared from scientific displays and publications. Access to key fossil sites in Patagonia became tightly controlled to preserve their integrity, limiting independent study and reinforcing how dependent our understanding is on a small number of extraordinary discoveries. Each new fragment had the power to reshape the narrative of prehistoric dominance. If Giganotosaurus, and potentially its relatives, hunted in coordinated groups, then the late Cretaceous ecosystems of South America operated under a level of predatory organization rarely seen even today. Only species like wolves, lions, and orcas exhibit comparable cooperative hunting strategies, and none approach the scale or destructive capability of these massive theropods. Entire herds of colossal herbivores would have lived under the constant threat of calculated, multi-directional attacks across open terrain with nowhere to hide. Modern simulations of predator-prey dynamics suggest that the presence of even a small number of such coordinated superpredators could reshape entire ecosystems, dictating migration patterns, population structures, and evolutionary paths. Their influence would not have been local, it would have been continental. If intelligence, coordination, and immense physical power once converged in predators of this scale, then Earth's past was governed not merely by strength, but by strategy. And in a world ruled by hunters that could think, pursue, and overwhelm together, survival was not determined by size alone, but by whether the predators had already chosen their target. Top 5. Carcharodontosaurus. The Carcharodontosaurus. In 1925, deep within the unforgiving expanse of Egypt's Sahara Desert, German paleontologist Ernst Stromer documented the remains of a colossal predatory dinosaur unearthed from the Bahariya Formation. The fossilized skull fragments revealed serrated teeth unlike anything previously recorded, long, blade-like, and finely ridged, resembling the cutting edges of a great white shark. Stromer named it Carcharodontosaurus, meaning shark-toothed lizard. The discovery hinted at a terrestrial predator of extraordinary lethality. Yet in 1944, during an Allied bombing raid on Munich, the museum housing Stromer's original fossils was destroyed. The specimens were reduced to ash, leaving behind only sketches, notes, and photographs. For decades, the creature's true scale and power remained uncertain, as though one of Earth's most formidable predators had been erased from history almost as completely as from the fossil record. The mystery endured until the 1990s, when paleontologists uncovered new and remarkably preserved fossils in Morocco. These remains revealed a predator stretching up to 43 feet in length and weighing approximately 7 to 8 tons. Its skull alone measured over 5 feet long, armed with serrated teeth reaching up to 8 inches, perfectly engineered for slicing through flesh rather than crushing bone. Biomechanical studies showed that Carcharodontosaurus delivered devastating slashing bites, retreating as its prey weakened from massive blood loss. This hunting strategy mirrored that of modern great white sharks, favoring precision and efficiency over brute force. Reinforced neck muscles and a lightweight skull allowed rapid, powerful head movements, turning each strike into a catastrophic wound. Carcharodontosaurus ruled North Africa around 95 million years ago, a time when the Sahara was a lush network of rivers, floodplains, and dense vegetation. This fertile environment supported enormous herbivores such as Pralotitan and Egyptosaurus, each weighing tens of tons. To prey upon such giants required not only size and strength, but calculated lethality. Fossil evidence, including bite marks consistent with Carcharodontosaurus dentition found on sauropod bones, indicates active predation or aggressive scavenging on these massive animals. The region was also home to other formidable predators, including Spinosaurus, suggesting a highly competitive ecosystem where dominance depended on specialization and precision rather than sheer power alone. Scientific understanding of Carcharodontosaurus evolved quietly but dramatically. Early reconstructions underestimated its size and portrayed it as a secondary predator. As new fossils emerged, anatomical models were repeatedly revised, and museum displays were updated with little public attention. Access to key fossil-rich regions in North Africa has often been limited by environmental challenges, political instability, and the prevalence of fossil trafficking, restricting comprehensive study. As a result, much of what is known about this predator is derived from a relatively small number of critical specimens, leaving significant gaps in the full picture of its behavior and ecological dominance. Modern biomechanical simulations suggest that a single well-placed bite from Carcharodontosaurus could remove pounds of flesh in seconds, initiating rapid blood loss and shock in even the largest prey. This method minimized risk while maximizing lethality, an evolutionary design refined for survival among giants. In an environment teeming with massive and dangerous animals, such efficiency was not an advantage, it was a necessity. If predators like Carcharodontosaurus shaped entire ecosystems through precision and calculated violence, then prehistoric dominance was not defined solely by raw strength, but by surgical lethality. And in a world where death could arrive in a single, perfectly executed strike, survival depended not on endurance, but on never being targeted in the first place. Top 6. Allosaurus, the Allosaurus. In 1877, during the height of the Bone Wars in the rugged Morrison Formation of the American West, paleontologist Othniel Charles Marsh described a predator that would come to define the Jurassic era, Allosaurus. But the true scale of its dominance did not emerge until decades later. In 1964, at a site in Utah now known as the Cleveland Lloyd Dinosaur Quarry, paleontologists uncovered a chilling concentration of fossils, thousands of bones, the overwhelming majority belonging to Allosaurus. Individuals of varying ages were found entangled together in a prehistoric graveyard. The pattern defied simple explanation. This was not a solitary hunter's story. It hinted at coordinated behavior, a possibility that challenged long-standing assumptions about dinosaur intelligence and social structure. The implications were profound. The Jurassic landscape may have been ruled not by lone predators, but by organized hunters. Allosaurus measured up to 39 feet in length and weighed around 2 to 2.5 tons, with some exceptional individuals growing even larger. Its skull was lightweight and flexible, equipped with dozens of serrated, blade-like teeth designed for slicing rather than crushing. Biomechanical studies revealed a unique hunting adaptation known as the hatchet bite. Instead of relying solely on jaw strength, Allosaurus used powerful neck muscles to drive its upper jaw downward like a striking blade, delivering deep, tearing wounds. This method allowed it to attack prey much larger than itself, including massive sauropods such as Diplodocus, Apatosaurus, and Camarasaurus. Fossil evidence supports this behavior, with sauropod bones bearing bite marks that match Allosaurus teeth, some showing signs of healing, proof that these attacks were frequent and often survived, at least initially. The Cleveland Lloyd Quarry provided the most compelling clues about Allosaurus behavior. Over 70% of the theropod remains at the site belong to this single genus, ranging from juveniles to fully grown adults. Geochemical analysis suggests the area was once a muddy trap or seasonal watering hole that ensnared large herbivores. Predators drawn to easy prey may have become trapped themselves. Yet the unusually high concentration of Allosaurus individuals suggests repeated group presence rather than random, isolated events. Additional fossil sites across the Morrison Formation reveal similar patterns, where multiple Allosaurus remains appear alongside large herbivores, reinforcing the possibility of coordinated hunting or at least complex social tolerance, an advanced trait for apex predators. Scientific interpretation of Allosaurus behavior has shifted significantly over time. Early reconstructions portrayed it as a slow, tail-dragging reptile with limited agility and intelligence. As fossil evidence and biomechanical modeling advanced, these depictions were systematically revised. Museum exhibits were updated, academic models reworked, and a far more dynamic predator emerged, fast, balanced, and behaviorally sophisticated. Despite this transformation, definitive proof of pack hunting remains elusive, and access to key fossil sites is tightly controlled for preservation, leaving crucial behavioral questions unresolved. Modern ecological modeling demonstrates that even loosely coordinated predators can dominate ecosystems by overwhelming prey through repeated strategic attacks. Allosaurus, with its speed, agility, and specialized killing technique, fit this profile with unsettling precision. Juveniles may have harassed and exhausted prey, while adults delivered lethal strikes, a division of roles seen in some modern predators, though rarely at such scale. If Allosaurus operated within even a primitive social framework, then organized predation emerged tens of millions of years earlier than once believed. The Jurassic world would not have been governed by isolated encounters, but by calculated persistent threats moving across the landscape in coordinated waves. In such a world, survival was not about outrunning a single predator. It was about escaping a system designed to ensure that eventually, escape would fail. Top 7. Mosasaurus, the Mosasaurus. In 1764, deep within the limestone quarries beneath the Dutch city of Maastricht, workers uncovered a colossal skull embedded in ancient marine rock. At first, it was mistaken for the remains of a giant crocodile or an unknown whale. But as naturalists across Europe examined detailed sketches and casts of the specimen, it became clear that this creature belonged to a world far older and far more dangerous than previously imagined. The fossil, later named Mosasaurus, emerged during a time when the very concept of extinction was still debated. Its existence forced scientists to confront an unsettling truth. Earth had once been ruled by predators of unimaginable scale and power, and the oceans, long assumed to be stable and familiar, were once hunting grounds for something far more terrifying. By the late Cretaceous period, around 70 to 66 million years ago, Mosasaurus had evolved into one of the most formidable marine predators in Earth's history. Measuring up to 50 feet in length and weighing as much as 15 tons, its body was perfectly engineered for speed and control in open water. A powerful crescent-shaped tail, confirmed through exceptionally preserved fossils, propelled it with remarkable efficiency, while paddle-like limbs allowed precise maneuvering. Its skull was equipped with a double-hinged jaw and a second set of backward-pointing teeth on the roof of its mouth, known as pterygoid teeth. This biological mechanism functioned like a conveyor belt, pulling prey deeper into its throat and preventing escape. Once seized, survival was no longer an option. Fossil evidence reveals a predator with an extraordinarily diverse and aggressive diet. Inside preserved Mosasaurus specimens, paleontologists have discovered remains of fish, sharks, seabirds, sea turtles, ammonites, and even other mosasaurs. Bite marks on marine reptile fossils match Mosasaurus dentition with precise alignment, confirming violent encounters and frequent cannibalism. Chemical isotope analysis indicates it occupied the absolute top of the marine food web. With large forward-facing eyes and an advanced sensory system adapted for detecting vibrations and pressure changes in water, Mosasaurus could locate prey even in low-visibility conditions. In the vast inland seas that once split continents, such as the western interior seaway of North America, there was no refuge beyond its reach. As marine reptile discoveries expanded throughout the 19th and 20th centuries, Mosasaurus was gradually recognized as the apex predator of its time. Early interpretations that portrayed it as a slow, eel-like swimmer were replaced by sleek hydrodynamic reconstructions supported by soft tissue fossil evidence from sites in Lebanon and North America. These findings reshaped scientific understanding of marine reptile evolution, though the transformation unfolded quietly through academic revisions and updated museum displays rather than public revelation. Today, access to many of the most productive marine fossil sites remains tightly regulated, preserving invaluable data while also ensuring that each new discovery has the potential to redefine what is known about prehistoric ocean dominance. Ecological modeling of the late Cretaceous seas suggests that a single adult mosasaurus could control vast marine territories, influencing migration routes and population dynamics across entire ecosystems. Its presence alone would have reshaped the behavior of every marine species within range. Unlike modern oceans, where multiple apex predators share dominance, these ancient seas were often defined by the overwhelming authority of a single hunter. If Mosasaurus embodied the peak of marine predatory evolution, then the prehistoric ocean was not merely dangerous. It was systematically controlled. Every movement in the water carried risk. Every shadow signaled potential death. The balance of life beneath the waves depended on a predator designed for total supremacy. And if evolution once perfected such absolute dominance in the oceans, then the calm surface of today's seas conceals a deeper truth. Earth's waters have already proven they can belong entirely to a single, unstoppable hunter. Top 8. Sarcosuchus, the Sarcosuchus. In 1964, during a French-led expedition across the remote and windswept Ténéré Desert of Niger, one of the most desolate regions within the Sahara, paleontologist Philippe Taquet uncovered fossil fragments emerging from ancient rock formations. What initially appeared to be the remains of an oversized crocodile soon revealed something far more extraordinary. As excavation progressed, researchers exposed sections of a massive skull stretching over 5 feet long, lined with dozens of conical teeth designed for gripping and crushing prey. The surrounding sediments told an even more astonishing story. This barren desert had once been a vast network of rivers and floodplains teeming with life. And at the center of this prehistoric ecosystem ruled a predator of overwhelming power. Sarcosuchus imperator, the flesh crocodile. This was not merely a large reptile, it was an ambush predator capable of overpowering dinosaurs. Sarcosuchus lived approximately 112 million years ago during the early Cretaceous period. Fully grown individuals reached lengths of up to 40 feet and weighed as much as 8 to 10 tons, rivaling a city bus in size. Its skull alone measured about 5 feet long and housed more than 100 interlocking teeth, perfectly adapted for seizing and holding struggling prey. Unlike modern crocodiles, Sarcosuchus possessed a long, narrow snout with a distinctive bulbous structure at its tip. Known as a bulla, possibly used for enhanced sensory detection or acoustic signaling. Its eyes and nostrils were positioned high on the skull, allowing it to remain almost completely submerged while observing its surroundings, an ideal configuration for stealth predation. Biomechanical analysis suggests Sarcosuchus generated a bite force exceeding 18,000 pounds, more than sufficient to crush bone and immobilize large prey. Fossil evidence from the Elras Formation reveals that Sarcosuchus coexisted with numerous dinosaurs, including iguanodonts and large theropods such as Suchomimus. Tooth marks consistent with giant crocodiliform dentition have been identified on dinosaur bones from the region, supporting the conclusion that Sarcosuchus preyed upon dinosaurs that ventured too close to the water's edge. Its hunting strategy mirrored, but vastly amplified, that of modern crocodilians: silent approach, explosive ambush, and a devastating death roll that tore prey apart or dragged it underwater to drown. With dense osteoderms forming armored plating across its body, Sarcosuchus was both a lethal hunter and a nearly invulnerable opponent. The true scale of Sarcosuchus only became widely recognized in the early 2000s, when advanced reconstructions and digital modeling refined its size, strength, and ecological role. Earlier interpretations had significantly underestimated its dimensions and predatory capabilities. As updated models replaced outdated depictions in museums and scientific literature, the shift occurred gradually, largely unnoticed outside academic circles. Fossil recovery in the Sahara remains logistically difficult and tightly regulated, meaning that current understanding is based on a limited but highly significant collection of specimens. Each new discovery has the potential to reshape the perceived balance of prehistoric ecosystems. Ecological reconstructions of the ancient Sahara, then a lush region known as the Green Sahara, depict rivers functioning as concentrated hubs of life, drawing herbivorous dinosaurs in predictable patterns. Sarcosuchus exploited this reliability with ruthless efficiency. Unlike terrestrial predators that relied on pursuit, it depended on patience and precision. The attack, when it came, was instantaneous and overwhelmingly decisive. In such an environment, the most dangerous place for any dinosaur was not the open plain, but the water's edge. If Sarcosuchus dominated prehistoric river systems with such overwhelming control, then freshwater environments, often seen as sanctuaries, were instead zones of calculated predation. Survival depended not on strength or speed alone, but on the ability to detect a threat that revealed itself only in the final second. And in a world where even a sip of water could trigger a lethal ambush, safety was not defined by where you stood, but by whether something beneath the surface had already chosen you. Top 9. Tarbosaurus, the Tarbosaurus. In 1946, during a joint Soviet-Mongolian expedition to the remote Nemegt Basin of the Gobi Desert, paleontologists uncovered a massive skull emerging from crimson sandstone cliffs. The region was harsh, isolated, and shaped by relentless winds that slowly revealed secrets buried for over 70 million years. As excavation progressed, the team exposed the remains of a colossal predator, powerful jaws lined with thick, serrated teeth, and a skeletal structure built for dominance. The creature was later named Tarbosaurus batar. But what truly unsettled researchers was not just its size or strength. Nearby, they discovered the fossilized remains of prey species bearing unmistakable bite marks, along with evidence suggesting repeated predatory encounters in the same region. This was not merely a hunter passing through. This was a territorial ruler, and the Gobi Desert had once been its kingdom. Tarbosaurus measured approximately 40 feet in length and weighed between 5 and 6 tons. Though closely related to Tyrannosaurus rex, its anatomy revealed specialized adaptations for survival in the unique environments of late Cretaceous Asia. Its skull was slightly narrower, but reinforced for immense bite pressure, capable of crushing bone with devastating efficiency. CT scans of fossilized skull cavities revealed an advanced sensory system, particularly in olfaction and vibration detection, allowing Tarbosaurus to track prey across vast floodplains and forested regions that once covered the Nemegt Basin. Its forward-facing eyes provided strong depth perception, enabling precise and lethal attacks. Every feature of its physiology indicated a predator engineered for swift and decisive kills. Among the most compelling discoveries was a fossilized confrontation between Tarbosaurus and the armored dinosaur Sishonia, a relative of Ankylosaurus. The Tarbosaurus specimen bore severe injuries, including a damaged jaw consistent with a powerful defensive strike, likely from a tail club. Yet the predator had survived long enough for the bone to heal, demonstrating both resilience and repeated engagement with heavily armored prey. Additional fossil evidence, including a juvenile Tarbosaurus found alongside prey, remains showing adult bite patterns, suggests the possibility of age-structured hunting behavior, or at least shared feeding territories. This points to a level of ecological organization rarely attributed to large theropods, where experience and size may have defined hunting roles within overlapping domains. The understanding of Tarbosaurus evolved significantly over time. Initially classified as a variant of Tyrannosaurus rex, it was later recognized as a distinct apex predator uniquely adapted to Asia's ecosystems. This reclassification unfolded gradually through detailed anatomical comparisons and advanced imaging technologies, quietly reshaping paleontological consensus. Many of the most important Tarbosaurus specimens remain housed in restricted research collections, and the Nemegt Basin itself is tightly protected due to extensive fossil trafficking in the region. As a result, much of what is known about this predator is derived from carefully controlled studies, with new findings emerging slowly, but carrying profound implications. Ecological modeling of the Nemegt ecosystem reveals a landscape dominated by Tarbosaurus, where few predators could rival its power. Large herbivores such as Saurolophus and Therizinosaurus formed the backbone of its diet, while juveniles likely targeted smaller, faster prey. This life stage partitioning would have minimized competition within the species, allowing Tarbosaurus populations to maintain stable dominance across vast territories. Unlike ecosystems with multiple competing apex predators, this environment appears to have been shaped primarily by a single, overwhelming force. If Tarbosaurus truly operated as the uncontested apex predator of its domain, then entire ecosystems evolved under the constant pressure of its presence. Migration routes, herd behaviors, and survival strategies would have been dictated by the movements of this solitary ruler. In such a world, dominance was not shared, it was absolute. And when an ecosystem is shaped by a single apex predator with no equal, extinction is not the only force that can reshape the world. Sometimes all it takes is the disappearance of the one creature that held absolute control. Top 10. Quetzalcoatlus, the Quetzalcoatlus. In 1971, within the desolate expanses of Big Bend National Park in Texas, a graduate student named Douglas Lawson uncovered fossilized bones so vast and fragile that their true nature was initially difficult to comprehend. The remains were embedded in ancient rock formations, dating back approximately 68 million years. As excavation progressed, it became clear that these bones did not belong to any dinosaur known to roam the land, nor to any bird that had ever taken to the skies. They belonged to something far more extraordinary, a flying predator of unprecedented scale. Named Quetzalcoatlus after the feathered serpent deity of Aztec mythology, this creature redefined the limits of flight. And more disturbingly, it revealed that the skies of prehistoric Earth were once controlled by a predator the size of a small aircraft. Quetzalcoatlus possessed a wingspan estimated between 33 and 36 feet, rivaling that of a modern fighter jet's length and surpassing any flying animal known to have ever existed. Standing on the ground, it reached heights of up to 16 to 18 feet, comparable to a giraffe. Despite its immense size, its body was remarkably lightweight, constructed from hollow air-filled bones, reinforced with internal struts, much like advanced aerospace engineering. Its elongated, toothless beak functioned as a precision weapon, ideal for seizing and dispatching prey with swift, controlled strikes. Biomechanical studies indicate that Quetzalcoatlus launched into the air using a powerful quadrupedal leap, propelled by all four limbs, allowing it to become airborne in seconds. Once aloft, it could glide efficiently across hundreds of miles, conserving energy while scanning vast territories below. Contrary to early theories that depicted it as a coastal scavenger, fossil distribution and anatomical analysis now support a terrestrial stalking lifestyle. Quetzalcoatlus inhabited expansive inland floodplains populated by small dinosaurs, mammals, and reptiles. Its movement on land resembled that of a giant, deliberate stork, silent, calculated, and sudden in attack. With a beak capable of delivering lethal force and a vantage point towering above most prey, it required neither speed nor brute strength to dominate. Its keen vision, adapted for detecting subtle movement from great distances, ensured that little escaped its notice. From the ground or the sky, it was both observer and executioner. Scientific understanding of Quetzalcoatlus underwent a profound transformation over decades. Early reconstructions portrayed it as an awkward glider, barely capable of sustained flight. However, advances in aerodynamic modeling, wind tunnel simulations, and structural analysis revealed an animal exquisitely optimized for long-distance soaring. Updated models quietly replaced outdated depictions in museums and academic literature, fundamentally altering perceptions of prehistoric aerial ecosystems. Fossil sites in Texas and comparable formations worldwide remain tightly managed, and the rarity of well-preserved pterosaur remains ensures that each discovery carries the potential to redefine what is known about giant flight. Ecological simulations suggest that Quetzalcoatlus could patrol territories spanning thousands of square miles, linking distant ecosystems through its mobility. No land animal could outrun it over distance, and no environment, open plains, river valleys, or coastal regions, lay beyond its reach. Unlike terrestrial or aquatic predators confined by terrain, Quetzalcoatlus operated in three dimensions, transforming the sky itself into a domain of predation. Prey animals lived under a constant and inescapable threat, from above without warning. If the land was ruled by giants like Tyrannosaurus and the seas by monsters like Megalodon and Mosasaurus, then the sky belonged to Quetzalcoatlus, a silent sentinel drifting on thermal currents, watching for the slightest movement below. Its dominance completed a planetary network of apex predators, leaving no environment untouched by lethal precision. And in a world where danger could descend from the sky without a sound, the concept of safe ground may never have truly existed. Only moments when the shadow had not yet arrived. Across hundreds of millions of years, Earth was ruled by predators so powerful that survival itself became an art of constant vigilance. From the crushing jaws of Tyrannosaurus rex to the silent aerial dominance of Quetzalcoatlus, from the ambush-filled rivers of Sarcosuchus to the vast oceans patrolled by Megalodon and Mosasaurus, every corner of the planet was once under the control of a supreme hunter. These were not isolated threats, but components of a perfectly balanced and relentlessly efficient system shaped by evolution at its most unforgiving. Fossil evidence, biomechanical modeling, and ecological reconstruction reveal a world where apex predators dictated migration routes, population dynamics, and even the evolutionary paths of entire species. Their dominance was not accidental. It was the result of millions of years of refinement, producing creatures engineered for precision, power, and absolute control. Yet despite their supremacy, every one of them vanished, reshaped by planetary shifts, environmental upheavals, and the relentless progression of time. Today, humanity stands at the top of the food chain, protected by intelligence, technology, and global infrastructure. But this dominance is neither ancient nor guaranteed. The fossil record tells a clear and sobering story. No ruler of Earth holds its position forever. Apex predators rise, ecosystems adapt, and extinction eventually redraws the hierarchy of life. If evolution once created predators capable of ruling the land, sea, sky, and rivers with absolute authority, then the true question is not whether such dominance can exist again. The real question is whether humanity is the final ruler of Earth, or simply the next to be replaced. If these accounts of ancient titans have shifted your perspective on the history of our planet, please subscribe and like the channel. We are unearthing the prehistoric legends that time tried to erase. Help us cultivate the future of discovery. Our next treasury of ancient secrets will be revealed very soon.